January 1944, just before dawn. A bitter wind lashes the flat Michigan fields surrounding the largest factory on Earth. Inside, beneath a ceiling so distant it disappears into haze, thousands of lights flicker over a machine built for war. Not the bomber itself, but the plant that creates it. Steel rails vibrate as a fully assembled B-24 Liberator creeps forward on a conveyor, its polished aluminum skin reflecting the sparks of last-second welds. Workers, young women with rivet guns, men testing hydraulic lines with oil-stained gloves, step back as the bomber nears the open hangar doors. A supervisor eyes the clock on the wall. The minute hand crawls toward the next mark. Another B-24 waits only a few feet behind. Engines cold, wings clipped for space, already part of a timed procession that never sleeps. The factory exhales. The doors open to the winter dark. 1 hour, 3,000 parts, hundreds of hands, one more bomber born into a world at war. Yet none of this existed a few years before because aircraft, everyone believed, were too complex for assembly lines. But a single civilian looked at the skies filling with conflict and asked a forbidden question: why can't we build them like we build cars? And that idea would change everything. In 1940, the world was already on fire. Europe had collapsed into darkness under the weight of German blitzkrieg. Poland crushed. France erased in weeks. British cities bombed night after night by Luftwaffe terror. Across the Atlantic, the United States still clung to neutrality, its factories focused on cars and consumer goods. But leaders in Washington knew the truth. The storm would reach them soon. And if democracy was to survive, America would need an air force on a scale never before imagined. Heavy bombers became the symbol of that new scale. Machines that could cross oceans, strike deep into enemy territory, destroy factories, cripple supply lines, and return home alive. The U.S. Army Air Corps placed its hopes in two warhorses of the sky. The Boeing B-17 Flying Fortress, famous even before its legend was fully written, and the newer, more ambitious design, the consolidated B-24 Liberator. Sleeker, faster, capable of carrying heavier payloads to longer ranges, the B-24 promised reach that could rewrite the war. It had a shoulder-mounted wing with a unique high-efficiency design, tricycle landing gear for modern airfields, and a bomb load that outclassed early B-17 variants. On paper, it was the bomber the Allies needed, but there was a problem of staggering proportion. The B-24 was complex, more so than any heavy bomber of its day. Its streamlined structure and internal bomb bays demanded precise fitting. Its wiring and plumbing stretched through multiple compartments and gun positions. It took thousands of man-hours to shape aluminum, install systems, mount engines, test hydraulics, and ensure flight readiness. Traditional aircraft manufacturing relied on small teams of highly skilled craftsmen assembling planes like bespoke machines, each slightly unique. Production was slow, costly, and confined to a handful of aviation plants. Before the war, building even one bomber per day felt ambitious. Yet strategy demanded something far more extreme. Planners in Washington called for bomber fleets in the thousands, enough aircraft to fill entire skies from North Africa to the Pacific. The British pleaded for reinforcements. The Soviets, bleeding under German invasion, needed American power from the air. The United States faced a harsh mathematical truth. If bombers were to decide the war, factories would have to produce them not by the dozens each month, but by the hundreds. Every military leader knew the bottleneck. The aviation industry was brilliant, but small. Aircraft weren't cars. They weren't meant to slide smoothly down a line of workers. They had curves instead of angles, stresses instead of tolerances, and requirements that changed constantly as combat exposed weaknesses. Engineers insisted that shortcuts would cost lives in battle. Precision mattered more than speed. And so the war machine was trapped in a paradox. The most advanced bomber available was also one of the hardest to mass produce. As America quietly prepared for the conflict it could not avoid, the government faced a question almost too daring to ask. Could the science of mass production, the heartbeat of Detroit, be transferred to aviation? Could the streamlined flows that had once put cars in every driveway now put bombers over every front line? Whispers began among policymakers and industrialists. They looked west toward California, where consolidated aircraft struggled to keep pace with demand, and then toward the industrial Midwest, a region large enough, skilled enough, and hungry enough to build for war. They imagined a new type of factory, one that stretched beyond conventional limits. A plant where raw material entered one end and completed aircraft rolled out the other in a relentless, mechanical march against fascism. In Washington, the Army placed orders that dwarfed anything seen before. Contracts worth millions flowed into aviation firms. Steel, aluminum, and rubber were redirected from consumer markets to war production. Every ounce of industrial capacity would be required, and then doubled. But even with this shift, leaders worried. Even with every qualified aircraft worker employed, even with every aerospace plant expanded, it still wouldn't be enough. That was when someone proposed looking beyond the aviation world altogether, beyond the experts, beyond the boundaries of traditional craft, toward a civilian industry that already built machines fast, cheap, and everywhere. Toward Detroit. The city had already transformed the automobile from a rich man's toy into a tool for the masses. It perfected the rhythm of the moving assembly line, turned manufacturing into choreography, and measured progress by seconds. If any place could multiply output to war-winning levels, it was the Motor City, a beating heart of pistons and conveyor belts. And there, inside that industrial beast, stood the Ford Motor Company, the empire that once shocked the world by putting Model Ts on roads from California to Cairo. Ford owned enormous factories, vast workforces, and decades of experience in breaking complexity into simple tasks. To many, it seemed like the obvious choice. To others, it sounded insane because aircraft were not cars. Engines for bombers required aviation precision. Wings required flawless aerodynamics. Every bulletproof turret needed reliability under fire. One mistake in production could cost 10 lives over Germany. Skeptics argued that Ford's bold promises would end in disaster, that the scale and speed required would only produce flawed and dangerous machines. But inside Ford's ranks, one man saw something different. He saw not chaos and complexity, but flow and opportunity. He believed the bomber could become more than a machine, it could become a product. And if production could be mastered, the sky could become a factory floor that a civilian, not a general, would soon pitch a plan so audacious that aviation leaders called it impossible. His name was Charles E. Sorensen, and he had a wild idea about a bomber plant like the world had never seen, where Liberators would roll off a line with the regularity of a ticking clock at a place called Willow Run. And that is where this story turns next. Charles Sorensen was not a pilot, not a military officer, and not an aircraft designer. He was a factory mind, a master of flow, a man who saw machines as extensions of human organization. As vice president of production at Ford, Sorensen had spent his life refining the moving assembly line. He viewed time as the true resource of industry, every lost second a personal failure. When war clouds darkened the world, he understood something that few in Washington or even within the Army grasped. Victory would be determined not by the brilliance of design, but by the speed of supply. And speed was something Sorensen knew how to build. In early 1941, before the attack on Pearl Harbor, sorrows from Europe already pressed against American shores. Britain was fighting for its survival. Aircraft losses were staggering. The Roosevelt administration urgently searched for ways to turn American industry into the arsenal of democracy. The government approached Ford with a question both simple and revolutionary. Could the automobile giant build bombers? Most executives recoiled. The leap from building sedans to manufacturing four-engine heavy bombers was monumental. Henry Ford himself, once an ardent isolationist, was skeptical and wary of entanglement in a foreign war. He believed war was waste, but his company's prestige and a patriotic sense that America must prepare pulled him into the conversation. It was Sorensen who seized the moment. He traveled to Consolidated Aircraft in San Diego, where the first B-24s were being built. He watched workers hand-fit aluminum sheets and individually finished components. The planes took shape not in lines, but in clusters of activity, skilled artisans crafting each bomber at its own pace. To aircraft builders, this was normal. To Sorensen, it was chaos disguised as craftsmanship. He studied every movement, every bottleneck, every lost opportunity. And then, one night, as he examined the half-completed Liberator, an idea crystallized. He imagined a straight path, a long, unbroken line, where components flowed forward step by step until a bomber stood finished. It was the automobile assembly line, stretched into the shape of a wing machine. When he returned to Detroit, Sorensen proposed something unprecedented, a single, massive factory dedicated entirely to bomber production, not parts, not sub-assemblies, the full aircraft, end to end. The Army brass doubted him. Consolidated engineers scoffed. Building aircraft required meticulous fitting and constant adjustments. How could an unskilled worker rivet a bomber wing as accurately as a trained airplane mechanic? How could complex systems arrive on cue, aligned to the minute? How could such a project avoid collapsing under its own weight? Sorensen answered with blueprints, calculations, and something stronger, absolute confidence. He laid out the design for a plant so vast it defied measurement. A mile long from one end to the other, equipped with conveyors to move fuselages, wings, and sections in perfect sequence. Inside it, he planned stations so specialized that a new worker could master a single motion, repeating it until it became muscle memory. If an error appeared, the line would reveal it instantly. Efficiency would do what tradition could not. The location chosen was Willow Run, a stretch of farmland outside Ypsilanti, Michigan. It was remote enough to build without limits, yet close enough to draw on the manpower of Detroit and its suburbs. Ground was broken in 1941. The plant would soon resemble a city in itself. More than 60 acres under one roof, windows stretching into the horizon, rail lines feeding raw materials directly into production zones. It was the largest factory the world had ever seen. But building a bomber plant was only the beginning. Ford now had to fill it. Tens of thousands of workers needed to be hired, trained, organized, and retained. Many had never seen an airplane up close. Many were women, stepping into industrial roles for the first time as men enlisted and marched off to war. The workforce spoke dozens of languages, came from farms and factories alike, and carried with them every possible level of experience and fear. They would need housing, transportation, childcare, cafeterias, an entire community forming overnight around the factory's appetite. Challenges multiplied. Machine tools arrived late. Blueprints changed constantly as the B-24 design evolved. Engineers argued over tolerances and standards. Logistics snarled as supply chains stretched across the continent. And as the United States finally entered the war after Pearl Harbor, urgency intensified beyond measure. Americans wanted results. Bombers were needed now. Every step tested Sorensen's resolve. Traditional aviation companies watched from a distance, some hoping Ford would fail and prove that airplane production belonged only to experts. The Army Air Forces struggled to mediate between Ford and Consolidated, whose relationship was strained by disagreements about authority, quality control, and design changes. Even Henry Ford himself, aging and more unpredictable by the month, often clashed with the Army over oversight and union demands. Yet through all this turmoil, one belief carried the project forward. If Willow Run succeeded, it would redefine not just the war effort, but the very nature of modern industry. So the conveyors were installed. The tools were calibrated. The workforce clocked in. Raw aluminum sheets arrived on rail cars. Engines from Pratt and Whitney lined the floors. Rivets, wiring, fuel tanks, plexiglass turrets, every component destined to find its place along the mile-long march. The world held its breath as the first B-24 inched toward the daylight. What happened next would test whether a civilian idea, a factory's rhythm, could truly shape the fate of a global war. The success of Willow Run would not be determined solely by machinery or blueprints. It would be shaped by the human element, the countless individuals who stepped into a factory unlike anything before seen. At its peak, Willow Run employed more than 40,000 people. They arrived before sunrise, packed into buses and trains, pouring through the gates like an army in civilian clothes. Some were farmers who traded fields for riveting guns. Others were women who had never been allowed near heavy industrial tools, but were now asked to drill, fit, and weld metal that would soon take flight. America's workforce was transforming into something new, a force as essential as any combat division overseas. Training these workers was a monumental challenge. Aircraft manufacturing required accuracy to the millimeter. A single misaligned rivet could weaken a vital joint. Workers who had once installed bumpers or doors on automobiles were now responsible for systems that would endure flak, freezing altitudes, and the harsh physics of combat flight. The plant became a living classroom. Instructors guided newcomers through repeated drills, teaching them one precise motion at a time. Instead of building an entire airplane, each worker mastered a single thread of its creation, a handful of rivets, a section of wiring, a brace within a fuel tank. Over time, thousands of individual movements synchronized into one vast mechanical ballet. But Willow Run itself was more than a workplace. It was an industrial organism. The structure was so large that bicycles became common transport inside the factory. Conveyors ruled the rhythm, dictating when tasks must start and when they must be completed. Above the factory floor, catwalks allowed supervisors to observe progress like commanders surveying a battlefield. A wing assembly might move forward to the next station, while fuselage sections advanced from the opposite direction, each piece destined to meet with perfect timing. If a single part failed to arrive, the entire system shuddered and slowed. Every delay echoed like a warning bell. Feeding the plant was a logistical mission nearly as complex as the war itself. The supply chain stretched across America, aluminum from the west, rubber from the south, avionics from specialized factories along the coasts. Railroad spurs reached deep into Willow Run's core, delivering shipments constantly. Warehouses overflowed with crates labeled for each station, time to arrive just hours before installation. Inventory managers scrambled to prevent any shortage that could halt the line. Even a few missing bolts could strand a bomber mid-assembly, holding up the hundreds of workers behind it. To keep pace, Ford developed new systems of tracking and standardization, transforming chaos into choreography. Yet beyond the technical and logistical feats lay a deeper transformation, the creation of a community built around a war machine. Neighboring towns swelled with workers seeking lodging. Makeshift housing developments sprouted like temporary cities. Families relocated from distant states for the chance to support the war effort and earn steady pay. Cafeterias, clinics, and bus lines expanded daily, trying to serve a population that doubled and tripled as Willow Run devoured manpower. Daily life was shaped by the rhythm of shifts. Children learned to sleep through the roar of aircraft engines. Wives became breadwinners. The idea of a home front turned literal, industry and life merging into one. Inside the plant, pride and exhaustion lived side by side. Workers understood that their labor carried real consequences. Each bomber leaving the factory meant crews had a fighting chance, and each delay meant soldiers waiting for support that might not arrive in time. Bulletin boards tracked production targets like battlefield reports. Supervisors reminded crews that speed could end the war sooner. The clock mounted high above the line became a symbol of hope and pressure, ticking relentlessly toward the next rollout. Still, the strain was constant. Turnover was high. Training never stopped because the flow of new recruits never ceased. Illness and fatigue spread through the workforce. Labor disputes simmered, especially as unions pushed against Ford's historically hard-edged management style. Mistakes happened, sometimes dangerously. Quality inspectors became guardians at every stage, ensuring that a defect never passed unnoticed because somewhere, someday, That defect could destroy a bomber and the 10 men inside it. Despite every obstacle, the human engine of Willow Run continued to strengthen. Workers grew more confident, more skilled, more efficient. The line began to move with greater consistency. Sub-assemblies arrived closer to schedule. Teams kept pace with the ticking clock above them. The factory's colossal heartbeat steadily quickened. What had once appeared impossible, unskilled workers crafting one of the most advanced aircraft in history, now seemed within reach. And yet, Willow Run had only begun to reveal the full complexity of its transformation. Beneath the growing rhythm of human labor and assembly line flow, deeper challenges loomed. Technical compromises, leadership battles, and the evolving demands of a global war. These would define the next set of angles, the ones that determined whether speed could coexist with precision and whether the bomber built like a car could survive the fires of combat. As Willow Run pushed forward, its greatest challenges shifted from the human and logistical to the technical and political. The B-24 was not a simple aircraft to mass produce. Its highly efficient Davis wing provided remarkable lift and range, but it demanded exact structural alignment. The internal bomb bay, split into two narrow chambers, required intricately fitted hardware. Gun turrets protruded from a nose, belly, tail, and sides, each housing machine guns that needed flawless operation when German fighters attacked. Every hydraulic pump, every oxygen line, every cable had a function under the brutal pressures of high-altitude warfare. And so, while the assembly line accelerated, engineers struggled to stabilize a design still evolving under combat feedback. Standardization became a battlefield of its own. Aviation experts insisted on constant modifications to improve survivability. Heavier armor, new turrets, altered fuel systems, improved navigation equipment. Each change forced the assembly line to pause, retool, and adapt. Ford's engineers fought to freeze the design, to lock the Liberator into a buildable form. The Army Air Forces and Consolidated Aircraft countered that improvements saved lives. Tension mounted. The question was no longer whether Ford could build bombers quickly, but whether the bombers they built would be identical, interchangeable, and combat-ready the moment they left the line. Then came leadership struggles, a clash of industrial egos and wartime urgency. Consolidated, creator of the B-24, feared losing control of its own aircraft to a car company with little aviation heritage. Ford, accustomed to dominance in auto manufacturing, resisted oversight from military inspectors who demanded accountability for mistakes measured in human lives. Negotiations often turned bitter. Meetings stretched for hours. Meanwhile, the war did not pause. Quality issues emerged on finished aircraft, systems that leaked, panels that didn't align perfectly, wiring that needed rework at the airfield. The Army fielded teams to correct flaws before the bombers could join combat units. For critics, this proved that planes could not be built like cars. For advocates, it was simply the learning curve of a revolution. Yet even at their roughest, Willow Run aircraft contributed where they were most desperately needed. Across the Atlantic, in the vast skies over Germany and Italy, Liberators joined daylight bombing raids that tested the limits of air power. Their long range made them invaluable in the Mediterranean, securing sea lanes, striking oil fields, and crippling Axis supply lines. In the Pacific, they hopped across remote islands, hunting Japanese shipping and bases. Crews knew that every aircraft in their formation represented a victory of logistics and labor thousands of miles away. The sight of dozens, then hundreds of gleaming B-24s gathering for a mission told a story no production statistic could fully capture. Still, there was a moral weight that shadowed Willow Run's achievements. The bombers they produced were built to destroy factories, bridges, fuel depots, and inevitably the cities around them. Workers in Michigan found themselves contributing directly to suffering they would never witness. Yet, the logic of war was merciless. Overwhelming force in the air might shorten the conflict and save more lives in the long struggle ahead. Many workers convinced themselves of this equation. Others never reconciled the contradiction. They tightened bolts and riveted panels knowing that each precision-fit piece would carry explosive vengeance overseas. But perhaps the most profound angle was psychological. The realization that the war was as much an industrial contest as a military one. The Axis powers could field skilled soldiers and advanced machines, but could they replace them fast enough? Willow Run represented the answer to that question. It turned the bomber into a reproducible asset, not a handcrafted rarity. Strategy shifted accordingly. American commanders began planning operations, knowing replacements would arrive. Losses, though tragic, were no longer fatal to the broader campaign. Quantity joined quality as a weapon. By 1943, the line at Willow Run moved with a rhythm once considered fantasy. The plant was still refining its processes, still overcoming setbacks, still wrestling with human and mechanical imperfections. But the convergence of thousands of workers, mountains of material, and civilian genius now hinted at something extraordinary. The dream that Sorensen had drawn in blueprints, a bomber factory operating with the precision of a clock, was finally approaching reality. The tempo of war demanded the impossible. Willow Run was beginning to deliver it. And soon, the world would witness the moment when this giant of industry reached a milestone so improbable that even its creators once doubted it. A four-engine heavy bomber emerging into daylight, not once a day, not once every few hours, but roughly every 63 minutes. That turning point, when the Conveyor's rhythm truly conquered the skies, is where the story now rises to meet its climax. In the early months of production, Willow Run seemed to confirm the skeptics' worst fears. Instead of smooth, synchronized motion, the assembly line lurched and stalled. Workers struggled to keep pace with demands they were still learning to master. Subassemblies arrived incomplete or out of sequence. Blueprints continued to change as the B-24 evolved under battlefield conditions. Aircraft rolled out of the factory only to undergo intense rework at airfields, where teams of specialists corrected the imperfections that slipped through the line. At one point, Willow Run barely produced one bomber per day, far below the lofty expectations Ford had promised the military. Rumors spread that the great factory was a disaster, a monument to industrial hubris. Yet buried within the chaos were signs of progress. Every delay revealed a flaw in process or communication, and every flaw was studied, mapped, and corrected. Specialized jigs aligned components with improved precision. Training programs matured, turning raw recruits into confident experts at their stations. Conveyor speeds were adjusted and broken into more manageable segments. Sorensen and his team walked the line constantly, clipboards in hand, watching the rhythm like physicians monitoring a heartbeat. Mistakes became lessons. Lessons became efficiency. The factory began to breathe. Morale shifted as well. Workers gained pride as experience sharpened their skills. Departments once overwhelmed by disorder began hitting their marks with discipline. Veteran instructors emphasized teamwork, each station building upon the labor of the one before it. Small triumphs accumulated into measurable gains. Hours shaved from assembly, interruptions resolved in minutes instead of days. Fuselage construction accelerated. Wing assemblies arrived on time. Final fitting, the most delicate stage, smoothed out through routine. The bomber line no longer felt like improvisation. It felt like momentum. By mid-1943, Willow Run was transforming into the machine Sorensen had envisioned. Output multiplied. Airfields adjacent to the plant filled with Liberators lined up like silver geese ready for migration. Pilots arrived to ferry these new war machines to distant fronts, sometimes departing in such rapid succession that the roar of engines became a continuous thunder. The Army Air Forces, once wary of Ford's capabilities, now recognized the factory's potential to reshape the air war. Washington breathed easier. The promise of mass production was finally being kept. Still, Sorensen wasn't satisfied. The goal wasn't improvement, it was mastery. He wanted the entire plant synchronized to a tempo that could be measured in minutes. He wanted the clock above the line to dictate the pace of history itself. And so Ford's engineers continued refining every detail: material delivery routes, maintenance routines, inspection checkpoints, workforce specialization. They brought in experienced managers from successful auto plants. They reorganized departments to eliminate bottlenecks. They expanded shifts to keep the line alive day and night. Willow Run became relentless, an industrial organism that did not sleep or waver. In the dead of night, rows of welding arcs flickered like constellations. By dawn, another series of bombers would be ready to roll. The enormous hangar doors opened again and again, revealing the latest Liberator to the cold sunlight. Each one was a triumph not only of engineering, but of coordination, the proof that Sorensen's theory wasn't madness. The factory scale defied comprehension. More than a mile of production line. Tens of thousands of workers on rotating shifts. Millions of individual parts moving with purpose toward a single goal. It was not just a factory, it was a concept realized in metal and motion. A demonstration that industrial power, when guided by innovation, could reach far beyond conventional limits. American generals touring Willow Run described it as a weapon in its own right, a strategic asset capable of influencing the war's outcome as decisively as any battlefield. For every bomber lost over Europe, another waited to take its place. The Axis could destroy airfields, fuel depots, and squadron after squadron of aircraft, but they could not stop the unstoppable flow emerging from Michigan. The world's largest aircraft factory was no longer fighting against itself. It was now fighting for victory. And then came the moment that would echo across history. After months of ceaseless refinement, Willow Run began to hit a rhythm so smooth, so precise, that even its boldest architect could only stare in disbelief. Supervisors watched the clock. Engineers tracked the intervals. Workers paused just long enough to witness the impossible. A completed B-24 Liberator rolled off the assembly line, and barely an hour later, another followed. The clock struck 63 minutes. The impossible had become routine. Willow Run had become a factory that built a heavy bomber almost as quickly as the war could send them into combat. That astonishing milestone and what it meant to the war effort forms the heart of what happened next. Sunrise washed over the airfield at Willow Run as another B-24 crept forward on the conveyor, its four Pratt and Whitney engines still silent. The hangar doors opened with hydraulic weight, revealing the runway beyond, a stretch of concrete that had become a portal to distant skies. Supervisors once again watched the clock, making quiet notes as minutes passed. All eyes focused not on the bomber rolling out, but on the line behind it, waiting for the next one to appear. And then, right on cue, barely more than an hour later, another gleaming Liberator emerged. 63 minutes. The benchmark everyone had once called insane had become the new standard. This wasn't just a symbolic victory. The moving line functioned like a massive, unbroken artery, pumping war machines into the Allied bloodstream faster than they could be shot down. Schedules were posted factory-wide, a bomber rolling out each hour, day and night. Conveyor operators adjusted speed to maintain a rhythm. Inspectors finalized paperwork as aircraft passed their stations. Engines were tested on the apron, propellers slicing through the Michigan air. Pilots strapped in, carried out checklists, and within hours of assembly, the aircraft that had rolled out of the plant could be airborne, headed for modification centers, then combat zones thousands of miles away. The psychological shift was immense. What once felt like fragile progress now felt like unstoppable force. Reporters visited the plant and wrote of a miracle in Michigan. Army officials who had doubted Ford's capabilities now praised its achievements publicly, recognizing that no other factory on Earth matched Willow Run's output. Sorensen's radical theories had not only taken flight, they had become foundational to the war effort. The plant had proven that complex aircraft could be standardized, mass-produced, and delivered with a frequency that overwhelmed the enemy's ability to resist. As the cadence solidified, the airfield surrounding the plant resembled a staging ground for a global campaign. Dozens of newly built Liberators were parked wingtip to wingtip, each one polished, fueled, inspected, and awaiting deployment. Ferry pilots, many of them women from the Women Air Force Service Pilots program, arrived constantly to fly the bombers to destinations across the U.S. for final armament and deployment. The sound of radial engines roaring to life became the anthem of Willow Run, a chorus of mechanical power signaling that another deadly machine was joining the fight. Inside the plant, morale surged. Workers celebrated when production targets were met and pushed even harder when they weren't. Clocks mounted high above the line became talismans of victory, a visible reminder that every tick mattered. Managers cracked down on delays, but they no longer needed to inspire belief. The proof was right before everyone's eyes. Bombers rolled out like clockwork. Teams competed internally, striving to outperform their own sections, knowing that any improvement, even a few seconds saved, meant lives preserved overseas. Across the Atlantic, the impact grew visible in the skies of war. Over Germany, Liberators flew in massive formations so densely packed that returning aircrews said they seemed like metal clouds blotting the horizon. They hammered industrial targets with relentless force. They flew supply missions, anti-submarine patrols, and long-distance strikes that stretched the Axis defenses to their breaking point. Each aircraft that fell, each black plume spiraling downward, was quickly replaced by another, fresh from Michigan's conveyor-driven colossus. By late 1944, production numbers stunned even military planners. Willow Run alone produced nearly half of all Liberators built during the war, thousands of aircraft that would carry crews across oceans and into danger. The plant had become the primary artery of the Allied strategic bombing campaign. It proved that industrial innovation could shorten wars, overpower tyranny, and redefine the meaning of a single hour. 63 minutes was no longer a measure of time. It was a measure of American resolve. But this transformation came at a human price. Workers endured endless shifts, noise that shook the bones, and pressure that never relented. Families lived their lives around the whistle that marked shift changes. Accidents occurred on the floor as fatigue took its toll. The city built around the plant suffered housing shortages and growing pains. Yet few regretted their choice to be part of something greater than themselves. In their hands, the war's outcome felt tangible, something they could literally build one rivet at a time. The mile-long line at Willow Run stood as the ultimate validation of Charles Sorensen's belief that with the right system, the extraordinary could become routine. Every bomber that moved from shadow into daylight carried that idea into the sky, proof that innovation could be as decisive as firepower. And while the war raged on, the pace of production never slowed. The clock kept ticking. The conveyors kept humming. Workers kept assembling the machines that helped define the course of history. But wars, no matter how industrially fueled, eventually end. And when the guns finally fell silent, Willow Run would face a new challenge altogether. What becomes of a factory designed entirely for war when peace demands its return? The answer to that question reveals the complex legacy of this place and the system that made bombers roll out every 63 minutes. By the end of World War II, Willow Run had achieved a scale of production unmatched in aviation history. Nearly 8,000 B-24 Liberators were assembled beneath its vast roof, a staggering portion of the more than 18,000 built overall. Those aircraft flew in every major theater. They patrolled the icy Atlantic, hunted submarines in the Bay of Biscay, and dropped bombs on oil refineries, munitions factories, and rail yards deep inside Axis territory. They helped sever Germany's access to fuel, the very lifeblood of mechanized war. And in the Pacific, their long range made them vital in campaigns that spanned remote island chains and endless ocean. The impact of Willow Run was not measured just in numbers produced, but in the strategic freedom it delivered. Allied commanders no longer feared attrition as they once had. When missions demanded pushing deeper into hostile territory, they could accept the risk knowing replacements waited in the wings. Air power became an industrial promise. Every bomber lost would soon be reborn in metal and fire back in Michigan. The skies grew crowded with Liberators, each one an airborne extension of the factory's unstoppable tempo. But as production soared, so did the human cost of using these machines in battle. The B-24 was a powerful weapon, yet flying it was perilous. Crews operated at high altitude in freezing temperatures, exposed to flak and fighters with little margin for error. Losses mounted. Many of the workers who toiled on the line, new men serving overseas, brothers, husbands, sons, and they built each aircraft with a personal prayer woven into its rivets. The morale boards at Willow Run displayed statistics of sorties flown and targets destroyed, but behind each success lay the lives of 10 airmen trusting every component to do its job. Back home, the relentless pace of the factory took its own toll. Shifts stretched long into the night. Workers endured repetitive strain, fumes, and noise levels that left ears ringing permanently. Housing shortages around the plant forced families into crowded temporary dwellings. Daycare centers struggled to keep up with the surge of working mothers. The war was total. No one escaped its demands, not even those far from the front lines. Yet the pride was unmistakable. When a Liberator rolled out of the hangar, workers often gathered to watch, momentarily silent beneath the roar of engines. They saw not a machine, but a collective achievement, the proof that their sacrifices mattered. In that moment, every hour spent beneath fluorescent lights felt connected to history. The promise Roosevelt had spoken, that America would be the arsenal of democracy, was alive here more than anywhere else. The military understood this morale connection. Pilots sometimes visited the factory to shake hands and thank the people who built the aircraft that protected them. Telegrams from overseas expressed gratitude in the simplest words. Your bomber saved us. Those messages were pinned to bulletin boards like medals. They reminded the workforce that efficiency was not just a metric, it was survival. But as 1944 turned to 1945 and Allied victory neared, the urgency that had once fueled Willow Run began to fade. The daily rollout that once symbolized hope now hinted at a future no one fully understood. What would happen when the order stopped? What would become of a factory designed to produce death-dealing machines once the world no longer needed them? That uncertainty cast a long shadow. The war had been a fire that demanded every ounce of industrial energy. Peace would cool the steel and test whether Willow Run's legacy would endure in a nation eager to return to normal life. The answer, like everything at Willow Run, unfolded in stages, and its consequences shaped the decades that followed. When the war ended in August 1945, the thunder of aircraft engines no longer echoed with urgency. Bombers still sat in rows on the airfield, but the world they were built for had changed overnight. Contracts were canceled. The Conveyor slowed, then stopped. Willow Run, once the beating heart of America's industrial war effort, faced the silence of peace. Tens of thousands of workers who had spent years in constant motion suddenly found themselves without purpose or position. Some returned home to farms or former trades. Others searched for new roles in a civilian economy, struggling to absorb its returning veterans. The community that had grown around the plant, bustling with the energy of wartime necessity, now felt suspended between what it had been and what it could become. The factory itself was too large and too advanced to simply abandon. America recognized the value of an industrial giant capable of pivoting so dramatically under national need. In the post-war years, portions of Willow Run shifted to peacetime manufacturing. Automobiles again rolled through its halls, including models for the struggling Kaiser Frazer Corporation. Later, General Motors took over sections of the facility, producing transmissions and other automotive components for decades. The transformation was uneven, but its message was clear. The tools of war could become the tools of peace. Yet the legacy of Willow Run was not measured in what it built afterward, but in how it changed the very idea of building. The methods refined their influenced every major industrial project that followed. Assembly line aviation became the norm rather than the dream of one determined civilian. fighters, transports, and even commercial jets would owe their mass production capabilities to the lessons forged in Michigan's wartime experiment. Sorensen's belief that complexity could be conquered through flow and precision spread across industries, reshaping factories from Detroit to Seattle and beyond. There was also a deeper legacy, one forged in the lives of those who worked there. Women who had riveted wings and wired fuselages returned to a society that often urged them back into the home. But many refused. They had proven their skill, independence, and willingness to build the very machines that defined a modern battlefield. Their experience challenged the boundaries of gender and labor in America. Willow Run, like so many wartime factories, helped ignite a movement that would continue long after the last Liberator flew. For the nation, Willow Run became a reminder of what could be accomplished when ingenuity meets necessity. The plant demonstrated that war was not only fought with weapons, but with ideas powerful enough to transform raw material into strategy. It showed that the line between civilian innovation and military success was thin, sometimes invisible, and it left behind a truth the world would not forget. In the age of industrial war, the factory could be as decisive as any front line. Over time, parts of Willow Run were demolished, its enormity reduced to match a quieter world. But some sections still stand, preserved in memory and metal. Museums and historians ensure that the story of the Liberator plant, the people who filled it, the man who envisioned it, and the clock-driven miracle it achieved, remains alive. Even now, the very name Willow Run conjures images of relentless production, of bombers emerging from shadows into sunlight, of a war fought with wrenches and welding torches as much as rifles and guns. The conveyors may have stopped, and the assembly line may no longer send war machines skyward, but the idea that once animated this place still moves beneath the surface of modern industry. It lives in every factory where efficiency and precision combine to meet challenges beyond imagination. And that idea leads us to the final reflection, a look at what Willow Run meant not just for the war, but for humanity's unending relationship with technology and power. In the quiet after the war, Willow Run stood as both a triumph and a reminder. Its walls had heard the hammering urgency of a world fighting for survival. Its floors had carried the weight of machines designed to destroy, yet also to liberate. What happened there revealed a truth that history continues to wrestle with, that the line between innovation and devastation becomes thin when humanity harnesses technology for war. Charles Sorensen's crazy idea changed more than the pace of production. It altered the nature of possibility. He proved that complexity could be simplified, that scale could be mastered, and that a civilian's vision could influence the outcome of battles fought an ocean away. His conveyor system didn't just move bombers forward, it pushed the boundaries of what nations believed they could achieve when necessity demanded the impossible. Yet the story is not only about machines. It is about people who rose each morning before dawn, who left fingerprints on cold aluminum, who counted hours not in pay, but in aircraft completed. It is about the unseen labor that gave pilots a fighting chance, that filled the skies with a force capable of turning the war's tide. Their courage was quiet, but it echoed in every Liberator that took flight. Willow Run taught the world that industry could become strategy, that wars could be won not only with skill in combat, but with discipline in production. And that revelation shaped the future. Factories everywhere adopted its methods. Nations understood that industrial strength was military strength. The modern era of mass-manufactured power had arrived. Today, when we see assembly lines producing the tools of everyday life, we can still trace a line back to that massive Michigan plant where bombers rolled out every 63 minutes. Willow Run endures as a symbol of ingenuity that answered the darkest moment in history, and of the extraordinary things ordinary people can build when united by a purpose greater than themselves. The war ended. The conveyor stopped, but the idea kept moving.